welcome back to this video lesson. Today we're going to talk about uh, looping statements, or what we control statements. Okay, so there are various control statements that exist, some of which you have while loops, okay, and you also have commonly called for loops. Okay, in this course, that's double O. In this course, we're going to look at while loops and for loops. We're also going to look at do whiles. Okay, so in that order. So today we're going to look at while loops, and when we speak of you know, condition statements, which are condition statements which are repetition statements, such as the while loops, for loops, and do whiles. We're simply talking about a structure in C programming or any other programming generally, which helps you repeat a certain task. So you might want to, let's say for example, count 1 up to 10. You are repeating a certain task. You might want to maybe you're creating a shopping list, so that shopping list will go on until the end. So as you can imagine, it keeps repeating itself over and over and over and over. Okay, so when you look at a task that requires something to be done a couple of times, you're going to think of repetition statements. Repetition statements such as while loops, for loops, and do whiles. So let's start with a while loop. A while loop structure is like this. While you open the bracket, remember whatever you open, you must close. So open and close like that. And in here, just like the if statement, you have what you call a condition inside there. So let me just add a comment there. And you have what you call a condition inside there. If this condition evaluates to being true, then everything here, for as long as this condition is true, this block here will keep repeating itself. Okay, so I can have something inside this block between this bracket and that closing as they are pairs. Whatever I put in here will keep repeating itself for as long as this condition remains true. Okay, so I can say int I is equal to 10. For as long as some condition which I've put here is true, I will keep being initialized over and over and over and over until this condition is no longer true. Okay, so let's look at a couple of examples. Let's say I wanted to count from 1 to 10. Okay, so the first thing that I will say is, okay, I need a condition. When do we stop counting? When we reach 10. So whatever we are doing, our base point or our maximum point, our limit is 10. So whatever value you are going to talk about must be below 10, must be less than 10. Okay, so in this case we can say x, which is some value which we don't know, must be less, if we want to include 10 also, must be less or equal to 10. Okay, I hope that makes sense. If we have this, we know that we can't just declare or put some value just like this. It's not known by the system. So what we have to do is that we have to declare this variable. So we're going to say int x, okay, and we're going to start from 1 itself. So what will happen is when the program reaches line 6, it's going to say x is equal to 1. So in that memory location somewhere in your system, x, which is the name of the variable, now at that memory location x you have a 1. So when it comes to line 8, in this line here, x is 1, so it's going to say 1 is less or equal to 10, which is true. Okay, so this condition right here is true, so it's going to execute whatever is inside here. Okay, the final thing that you have to remember is that this x must be incrementing. Why are we saying that? Well, because for as long as x is 1, it will never reach 10. So we need to do something that enables it to achieve this 10, so that this loop doesn't continue forever and ever and ever. Okay, so we can try to run it right now, and this the program will not stop. It will continue moving and moving and moving and going on. So let's try and run it. Okay, so it's compiling, linking. Okay, as you can see, nothing is happening. I can try and type, but nothing is happening. This program is in a state called an infinite loop, okay, which is a loop that doesn't end, because 1 is forever less than 10. Okay, so let's just close it. So in such situations, you always try to, not always, in some situations you need such programs which have what you call infinite loops, loops that continue forever. Okay, but in most applications you're going to want this condition here to end at some point. So how do we make sure that this condition, this x reaches 10? We have to say x is equal to x plus 1, or whatever you'd want. You would even say x is equal to x plus 5. I'm just saying plus 1 because I want to see it incrementing from 1 to 2 to 3 to 4 to 5. So line 13, what does line 13 mean? Line 13 means that at this point here, x, we know that x is 1. Okay, the program started from here, x is 1 is less than 10. So the program comes here and then it says 1 plus 1, since x is 1. Okay, 1 plus 1 is 2. That 2 will be given to the x. Then this loop, the while loop, will go back. Okay, it will go back because this condition was true. So it goes back. Now remember, x has been replaced here with a 2. So now x is 2. So it will say x, which is 2, is less than 10. Is that true? Yes. So it comes back here. Remember, x is 2. So 2 plus 1, x becomes 3. Okay, so x becomes 3 because the previous condition was true. It goes back again, x is 3, and so on until maybe x is 9. Okay, so x is 9. 9 plus 1, that's 10. So it comes back here. X is less or equal to 10. Remember, x is now 10. So 10, it comes inside, and now 10 plus 1 becomes 11. When it goes back out, 11 is less or equal to 10. No. So this program, or this section of the code here between this bracket and this bracket, no longer execute. It no longer repeats itself because now this condition is false. So for as long as this condition remains true, the code in here will continue executing. If this condition is true every time, the program will never end because it will keep repeating itself, just as we saw. Okay, so if we run it, it's actually going to, x will be 1, 2, 3, 4, 5, 6, 7 up to 10, except we can't see it because we haven't told it to print anything. Okay, as you can see, I'm just from running it, and it just let me just move in here. As you can see, it just keeps quiet and nothing really happens. Okay, so let's try and print out something. To print out something, okay, this we know, print f, open bracket, percentage, sorry, it's percentage d, because it's an integer, so we can that's why we're using percentage d. So print x. So now when we run this program, now it prints out 1 2 3 4 5 6 7 8 9 10, and simply just that is how you would actually repeat a task. So if you think about it, you're actually repeating this task. Whenever you're counting numbers, you actually repeat something every time. You repeat this operation here, addition of 1. When I say 1, I'm going to add another 1, so it becomes 2. So I'm repeating some task. This is the task that we repeat in our brains, in our minds, whenever we do that. If I tell you to count in even numbers, what you're going to do is, instead of adding a 1, you're going to add a 2. So it will be 2, 4, 6, 8, 10. Okay, so you keep repeating a certain task. So this is about repetition statements, and this is a while loop, a very important structure which you find very useful in different situations. Okay, so we'll look at other repetition statements such as the for loops and do whiles. Okay, I hope you've learned something. See you next time.